Thanks for stopping by my session on the future of service mesh. My name is Posta. I'm the global field CTO here at Solo. I've been here for over 3 years now, working with our customers to adopt Envoy-based and service mesh-based technologies. I just recently finished writing my 3rd book, Istio in Action. It should be available soon here from Manning in the next few days. And I've also put my contact information on the slide, so feel free to reach out and have questions or follow up afterward as you feel. So Solo, we've been working on application networking technology for the last 4.5 years now. We are the leader in this space. So open source communities like Envoy and Istio, so we've been involved with since the very beginning. We are on the technical oversight committee of the Istio project. We founded some of the working groups, and some of us have actually been running Istio for an extremely long time, including one of the first to run Istio in production. We recently closed our Series C round of funding at a $1 billion valuation, and that's really a testament to 2 big things. One, the people here that we have at Solo, and the customers that we're working with. So you can go to our customers page here and see some of the customers that we can talk about publicly, but you'll also hear directly from those customers here at SoloCon. Some of those logos are listed on the slide here. So what do we do at Solo? Like I said, we work on application networking technology based on Envoy Proxy, based on Istio service mesh, and we focus on abstracting the network so that you can improve developer experience, improve your security posture, and safely bring changes into production by consistently applying traffic routing rules and security policies and so on. Now in the past, or even present day, I guess, you can expect a heterogeneous deployment of networking technology, from gateways to SDNs to firewalls to public cloud VPCs and all of this stuff in between, running on VMs and containers and so on. What we want to do is abstract away the networking pieces, push the control and policy enforcement pieces as close to the applications as possible, and then give a centralized management and governance workflow on top of that to actually operate this kind of stuff in production. The 2 main products that we have here at Solo are Glue Edge and Glue Mesh. Glue Edge is our enterprise API gateway, or modern API gateway, built on Envoy Proxy, and Glue Mesh is our enterprise service mesh built on top of Istio. Now, the gateway worlds and the service mesh worlds are converging. So you'll see in the rest of this talk, and probably from some of our customers, how the edge use cases like rate limiting and validating untrusted traffic using various security mechanisms and request transformation and these types of things, the edge is becoming blurry, and bringing some of those capabilities into the mesh and managing this from a single control plane is operationally probably a better approach, and that's what we're working on here at Solo. Here's an example of a large-scale deployment of mesh at one of our largest customers, deployed across multiple lines of business. You can see how the mesh and the gateways kind of complement each other to enable this very fine-grained security and traffic routing policy and observability throughout the system without having any centralized bottlenecks. And it's a really important part, is that we're decentralizing a lot of these pieces. Like I said, you'll see, go check out the talk from T-Mobile and Constant Contact and USAA and others will go into a little bit more detail about how they improved their developer experience, how they drove down the amount of time it takes to make changes in production because of this very fine-grained control over the network. So let's talk about what's coming next, how the service mesh is evolving, and what we can expect in the innovation and so on that's happening in the communities, and more importantly here at Solo, because we're driving a lot of that. And the first point to make is the future of service mesh and the innovations that we'll be seeing, they come from the data plane or around the data plane. So if you're familiar with the service mesh lingo, the data plane is the proxies through which the requests and the messages are traveling to get from service to service. The control plane is the piece that's configuring those data plane components. So we're talking specifically about the data plane, and this is not all that novel of an idea. In fact, in 2019, I spoke about this at Service Mesh Con. It was, the talk was called The Truth About the Service Mesh Data Plane, because everyone was so focused on the sidecar deployment pattern. But in that talk, I pointed out, well, you can do some of this stuff to optimize the data plane by putting it into the code itself, or you can use shared gateways, or you can use centralized gateways. And so that the data plane is a spectrum. And we're going to continue to see that in the following slides as we go in a little bit deeper. But a lot of this is known, and we've tried a lot of this. We know where the trade-offs are and where the issues are in these various different types of deployments. But let's make them explicit and let's talk about them, because other folks are saying let's just move to a centralized gateway or a shared proxy per node model. But that's not we've been there and we've done that. Let's look at some of the trade-offs for doing that. So like I said, the data plane is where the innovation is happening. That's where the future of service mesh, it hinges on. So it's important to pick the right data plane for your application networking, for your service mesh technology. We believe here at Solo that Envoy is that right data plane. It's extensible. It was built with these dynamic environments in mind. It's in an open source, extremely vibrant community, and it's been adopted in a lot of the service mesh distributions. But so what we're going to focus on is the data plane. How can we extend it and make it more powerful going up the stack? So that's where the GraphQL pieces come in, and you can take a look at some of the other sessions here at Solo and get a little bit more detail about that. But then we'll look at going down the stack. So how can the CNI, how can the traditional networking, how can eBPF, these types of things create a safe networking world where we can run the proxies maybe not as sidecars, but as other shared gateways and shared infrastructure, but try to get the best of both worlds. So let's take a look. The first is extending the proxy. And what we've done here at Solo is we've taken the Envoy proxy, the base Envoy proxy. We've built additional filters and capabilities on top of that. Now, Envoy was built specifically to be able to extend it. Its filter architecture means that you can build filters, layer them into the proxy, and extend the capabilities of the proxy. And if you don't want to build things directly into the proxy, you can use WebAssembly to dynamically inject filters into the proxy. So extensibility is a core capability of Envoy and is very important to how the service mesh will continue to evolve. So you can take a look at some of the filters on this screen that we've already implemented, that we've built. So things like request transformation, things like Lambda invocation, so you can directly call and replace ALBs, AWS API gateways, all that stuff. You don't need all that stuff to be able to call Lambdas from our proxy. Things like data loss prevention, web application firewalling, SOAP translation, all of these things we've built as filters into the Envoy proxy. So now we have a much more powerful proxy, typically used at the edge in the gateway use case, but can also be used in the service mesh for the service-to-service communication use case. Now we've taken this a step further, building a GraphQL filter into Envoy, and not just a GraphQL query parser, but an actual GraphQL engine. So if we take a look at the next slide, we can see that the engine is made up of a resolver engine. So you can specify the GraphQL schema as a declarative configuration, and then also specify how the individual fields get resolved using some of the out-of-the-box resolvers. So things like a REST-based GraphQL query, or field resolver, gRPC, caching, and if there's a resolver that we don't have out of the box or that you need to customize, we can actually inject WebAssembly-based resolvers. So extending Envoy, GraphQL, and moving up the stack or up the layers, the networking layers, is an extremely powerful thing, and brings a lot of power to the service mesh, and is definitely the future of Glue Mesh and the service mesh that we're building here on top of Istio. The second part to the future of service mesh is how we optimize the data plane, or the placement of the layer 7 proxies. Now, specifically, why we might want to think about doing that is around optimizing for performance, optimizing for resource usage. Some of the larger deployments of a service mesh may see some benefit to this, but we also have to keep in mind the extensibility use cases that we mentioned, or the operational use cases around upgrading and minimizing impact. The data plane of a service mesh or application networking infrastructure is vital. It's critical. The requests and the messages are flowing over these proxies. So upgrading and operating on these things is extremely sensitive. And then lastly, we also want to keep a tight security boundary. If there are incursions or exploits, that we want to contain them to just the smallest blast radius that we can. So when we think about optimizing the data plane and the placement of the service proxies, we have to think in terms of these dimensions. What are the things that we're hoping to achieve, and what are the trade-offs that we are willing to make? So the first pattern that we'll look at is the service proxy, or the sidecar pattern. And in this pattern, in the service mesh, the sidecar proxy gets injected right next to the application instance. So in Kubernetes, you can think of this as another container in the Kubernetes pod, and they run atomic. The life cycle of the application is atomic with the proxy. When the application talks to another application, it talks first through its local proxy. That proxy then applies security policies, traffic routing rules, collects telemetry, and so on, and then carries on over the network. When it gets to the other application, then it goes through its service proxy, which then does rate limiting and request authentication, authorization, this type of stuff. Again, applies traffic policies and so on, and then eventually gets to the application. Now, deploying a sidecar next to each application instance has its benefits and it has some of its drawbacks. So some of the drawbacks, you're deploying a proxy next to every application instance across thousands or tens of thousands of applications. This can be a lot of overhead. And we do see this come up with I would say, a smaller fraction of our customers who are worried about this level of overhead, but it does come up. Now, in this model, however, a lot of customers, I would say, that we have, they favor the trade-off for things like feature isolation, right? Where applications can be configured independently from others. Things like connection pulling, things like timeouts and retries and budgets and these types of things, or extensibility. Maybe they're injecting WebAssembly filters and this kind of stuff. And they don't want that to affect other applications. So they can configure it specific to the needs of a specific application without worrying about impacting the others, because they all have their own sidecar proxies. The others is the security granularity. So when a request comes into an application, the proxy can say, hey, I represent application A, and this is application B calling me. All right, is that allowed to happen? All right? And we can get that scope down to the level of the application instance. Alternatively, sharing a centralized gateway or a host-based gateway, you're not down to the level of the application instance. You're down to the level of the host, right? Now, still something has to verify or assert the identity of the actual running applications at the end. The last is upgrade impact, right? So we can very finely, in very fine-grained way, upgrade the sidecar proxies independent of the rest of the applications. So it gives us a better control over that blast radius if things start to go wrong. Another approach that comes up that is also a valid deployment model is sharing the proxy for the entire node and having the applications, when they communicate with each other, the traffic flows through the node-based proxy. And if it crosses into a different node, then it goes from that proxy on its node to the proxy on a different node, right? And then the traffic continues on from there. And you can use things, this is where it's very handy to have CNI level control, maybe using things like eBPF and rerouting the traffic and forcing the traffic through these layer 7 proxies. And this enables the applications to not know or have to care about the sidecar proxies. And it almost gives it a little bit more of a secure, there's some security properties here where the application can't go around the sidecar because you're using the lower layers in the network to force traffic through the proxies. Now the benefits, obviously, to this one is better resource usage. You can use a single proxy per node versus maybe hundreds of proxies per application instance. So the resource overhead is much more optimal. You lose, however, the feature isolation. Envoy proxy is a single process. It is not very well isolated inside the proxy itself, as far as resource consumption and so on. Especially not if you're going to extend the proxy. If you're going to inject WebAssembly filters and Lua scripts, these kinds of things, you can't really get the level of isolation that you want, that a lot of our customers are really interested in. The second is the third point here really is around the security granularity. You do get the benefits of not allowing sidecars to go around the proxy, but you lose the fact that that node or that proxy represents that single node, right? The actual application identities kind of get watered down and lost because the proxy doesn't actually live with the application instances. The fourth and the last here is upgrade impact. When you're sharing a proxy with a lot of other different applications, it becomes much more important how you upgrade that. Because if that upgrade goes wrong, that blast radius takes out that whole node and all of the applications on that node. So you lose some of the, you gain, you can see in this chart, it's pretty optimal in terms of resource usage, but you lose some of the isolation and the security benefits that you might get with more fine-grained or sidecar deployment. Another approach is to kind of meet in the middle, where instead of having a proxy per service instance on one end and a proxy per node or some shared gateway on the node at the other end, we can do something in the middle. So we can say we can have a service proxy per service account, which may represent an application and multiple instances of an application on a single node. And we share that between those instances. And we can use the CNI plugins and the eBPF and so on to force traffic for a particular service account through its own proxy. And so it can be hidden away, virtualized away. You get some of the benefits of the resource overhead. You get some of the benefits. You still get the feature isolation and the lower blast radius for security and upgrade impact. And you sort of meet in the middle. Now the last one that we'll look at is another approach that has come up that involves taking the sidecar proxies and moving them completely off the node. maybe putting them in specialized part of the architecture, and using either the CNI plugins directly or a smaller, lightweight micro sidecar, micro proxy that lives with the applications that can still do very basic things like mutual TLS and connecting to a layer 7 Envoy proxy that lives somewhere. We don't know, and it doesn't matter really where it lives. But the same policies that you have with the service mesh, the same traffic and security API that you might use can be used for any of these types of deployment models. And then if you look at this chart, you still have some of those trade-offs around resource usage, performance, and feature isolation, security, and so on. So at the end of the day, when people are deploying large-scale service mesh and application networking architectures, what they care about is my traffic secure? Can we control the traffic routing when we make new deployments, doing canary releases and this kind of thing? Can we fail over? Do we have high availability? Do we have the tenancy that we have for our different teams to be able to configure their applications? And then, once those things are in place, you can start to optimize the actual resource usage, isolation properties, and these kinds of things as you go and refine the architecture. And here at Solo, Glue Mesh is our enterprise service mesh. It's based on Istio. It has all of these things, multi-cluster aware API, built for global load balancing and failover across clusters, things like multi-tenancy, and allowing different teams, different parts of the API, and not sharing the entire service mesh API with them. And then lifecycle upgrades and these types of things can be built into, Glue Mesh has all of these things. Now, the next things that we are enabling are the GraphQL pieces, like I talked about earlier, and this is being built at the data plane layer. So you'll start to see, actually at SoloCon now, we're announcing the GraphQL component inside of the Edge gateway, but very shortly that'll be coming to the rest of the mesh as well. And then on the other side, using eBPF, using CNI plugins to be able to give you options for how you place the proxies in your architecture. So from layer 7 connectivity, security policy, to enabling new protocols to expose data, to improving the security model and the configuration model between layer 7 and layer 3 and 4. And giving you ways to optimize the usage of the proxies. These are going to be core differentiators here in Glue Mesh and driving the innovation that's happening in this space. And as we continue to work with our customers and get feedback, all of this stuff will continue to improve. So you can see here in this last slide, this is we're tackling layers 7 down to 3 and 4. Including the GraphQL, which, multiplexing, I guess we're calling layer 8. But you can see that we're abstracting the network. We're focusing on the ease of use and large-scale deployments of technologies like this. That's it here. Thank you for joining my session. Please go check out the sessions from our customers, some of the roadmap and update sessions, and of course, check out the keynotes that'll be kicking off SoloCon each of the days. So I'm Christian Posta. Thank you so much for joining, and look forward to chatting offline.